Okay, good morning. Welcome to
FunMath177.
FunMath number 177. Today, we're taking, I hope I have enough markers here. Today we're going to take a look at an interesting thing about these quadratic equations. We've read in section 10.1 of Art of Problem Solving's algebra book, looking at quadratic expressions like this one, x minus 3 times x plus 2.
Mm-hmm.
And I just wanted to show you what this looks like. And the way I want to show it to you is I'm going to break it down into two pieces. We're going to look first at y equals x minus 3, and then y equals x plus 2. And then we're going to talk about what it looks like when we multiply these two things together. So y equals x minus 3. First of all, we spent a lot of time talking about that in the last couple of chapters. What is y equals x minus 3? What sort of shape is that?
That's a line.
It's a line. Okay, where does it cross the x-axis? What x value makes y equals 0?
When x is 3.
When x is 3. So I'm just going to make some little ticks here. When x is 3, y equals 0. And what's the slope of this line?
The slope is 1.
Why is that?
Because it's y equals 1x.
Okay. So the slope of 1 is a 45 degree.
Mm-hmm. Something like that.
Something like this. So here's our first line. Okay, now what about y equals x plus 2? What x value?
When x is minus 2, y equals 0.
When x equals minus 2,
and the slope is 1 as well.
Slope is 1 as well. So in this case, I've got two parallel lines. And I'm going to multiply them. I'm going to multiply the y values together to get this. Okay?
Mm-hmm.
Now, this is a little bit complicated, so let's talk about it. First, let's look at the region over here that's when x is bigger than 3. Notice this line's positive, this line's also positive over here, right?
Mm-hmm.
So it's going my graph of this is going to start at 0, because when I multiply anything by 0, I get 0.
Yeah.
And it's going to be positive, and it's going to get more and more and more positive. That. And the reason I didn't draw it as a line is because I don't really know, right? It might be
a parabola.
It might be not a line. Now, let's look at over this way. Actually, you know what? This brown doesn't show up super well on the camera, so let me just draw it in black. Over here, to the left of minus 2, this is negative and this is negative. So what's a negative times a negative?
It's a positive.
It's a positive. So I'm going to start at 0 because this line is 0, and then everything is a negative times a negative, so I'm going to go up this way. Okay, when I multiply them together. Now how about when I'm in between here and here? Okay, well this line's negative.
Yeah.
So the y values are negative. This line is still positive, so what's a negative times a positive?
It's a negative.
It's a negative. So I've got a negative times a positive, and I'm starting at 0 here and ending at 0 here, so I'm just kind of looping like that.
It's a parabola.
It looks
like a smiley face.
It looks kind of like a smiley face, right? This particular shape is called a parabola. So I just wanted to talk you through sort of how you could even think about what this shape looks like, just based on what you know, based on lines, and based on some simple mathematics arguments about just positive times a positive, negative times a negative, and negative times a positive. Gives you kind of an idea of the shape. What's another way to understand the shape of this graph?
Well, we can just multiply it out right from here.
We could multiply it out. That'll tell us an equation for the graph, and that would be, what would it be? X cubed, x squared, minus x minus 6. If we multiply that out, that's what we would get. But that doesn't really help us understand the shape. We could make a plot. We could plot some points. Or what's the other thing we've been doing to look at this shape?
We've been using Mathematica.
Yeah, we could use Mathematica. That's been pretty fun. All right. Good job. Good job. Good job, Mr. Prince.